Hey guys, so today we're going to be looking at simplifying radicals, which you probably have seen square roots before in middle school, and you should be familiar with the term perfect square. Okay, so I want to start off by going over a few of the perfect squares. We know that a perfect square means that I can multiply that number twice, and it gives us a product, and that product would be a perfect square. Okay, so 1, 4, 9, 16, 25, 36. Those are our first few perfect squares, and this is the table for the perfect squares up to 30. Of course, there are infinite amount of perfect squares because I can keep going on and on. But we have 1 because 1 times 1. We have 4 because 2 times 2 is 4. We have 9 because 3 times 3. We have 16 because 4 times 4, so on and so forth. So I take a number, multiply it times itself, and that is a perfect square. Okay, so when I find the square root of it, it's kind of like I'm just undoing it. Okay, I'm asking myself, what two numbers, or what number can I multiply twice to get the 4? And that number is 2 because 2 times 2. Okay, square root of 16 is going to be 4 because 4 times 4. Square root of 25 is 5. Square root of 100 is 10, and the square root of 144 is 12. Okay, so that should just be like a quick review. You have seen this part in middle school. If you haven't seen it before, you may want to get with me in tutorial so I can make sure that you understand perfect squares, okay, and square roots. What we are going to be looking at today is you may have a case where they do not give you a perfect square inside the radical, okay? So here they gave me an 8. So 8 is not a perfect square. It's no number that I can multiply twice to get 8. So what's going to happen is I'm going to have to think of my other factors of 8, okay? So I'm going to think of 4 and 2, okay? So since I rewrote that, I'm going to circle the 4. The reason I'm circling the 4 is because 4 is the perfect square, and I can break that down, okay? Because the square root of 4 is 2. So 2 is going to come out, and then here I'm going to have 2 on the inside because that was left, and that's my answer, 2 square root 2, okay? My next one, I can rewrite this as 4 times 5. Okay, because the square root of 20, okay, I know that I can rewrite that as 4 times 5, okay? You may be thinking, well, why didn't she pick 1 times 20 or 2 times 10? I'm picking 4 times 5 because 4 is a perfect square, okay? So I'm going to circle my perfect square. The square root of 4 is 2, so 2 is going to come out, and 5 is going to stay in. So I have 2 square root 5. Okay, now another way you can do this, let's say you didn't get that way, I can do this by using prime factorization or factor trees, okay, which most of you have seen factor trees before. So if I do a factor tree with 8, okay, this is saying 4 times 2, then I will keep going and go 2 times 2. Now, you know, when you do factor trees, you want to stop when you have all prime numbers. So this is prime, all these are prime numbers. Okay, this is really called prime factorization. So make sure you know that just in case on the test we ask you that. Okay, I know my spelling is off. Okay, so this 8 is like saying 2 times 2 times 2, okay? So one thing I like to do is circle my pairs. So I have a pair of 2s. The 2 is going to come out, and then I like to underline what's left alone. So what's left alone is going to stay inside. So that's going to be 2 square root 2. Does that make sense? I hope so. All right. So let's say I did 20 that same way. I would have 4 times 5. Or let's say I did 10 times 2. Okay, so for this one, you don't necessarily have to choose the perfect square. You just want to keep going until it's factored out to all prime numbers. Okay, so 10, I have 5 and 2. Okay, and 5 2 and 2 are all prime numbers. So I like to circle the pair meaning 2 numbers. Okay, so I have 2 2s. So that's going to come outside. And then what I'm underlining is going to stay on the inside. So my answer is 2 square root 5. Okay, let's say I did 32 that same way. Okay, that's my next one. So I'll have, let's say I did 8 times 4. Okay, from here, I have 4 times 2. Then I have 2 times 2. Okay, I can stop there because these numbers are prime. And then here, I have 2 times 2. Okay, and I'm going to still circle my pair. So this is a pair. This is a pair. So 2 is going to be coming out. That group is gone. I have another pair too, so that's going to come out as well, and I'm going to be multiplying. Then I still have these here. There's 2 here, so 2 is going to be on the inside. So my answer would be 4 square root 2. Okay. Now let's say I did it the other way, and I did my highest perfect square. My highest perfect square is 16. So I'm doing 16 times 2. Okay, the square root of 16 is 4, so I have 4 square root 2. Okay, so that's just a few examples. I'm going to go ahead and go to IXL so we can get right into it and nobody's confused. Okay, and I'm going to do it. I'm going to do just a few examples. Okay, so this one gave me the square root of 12. So I'm going to do it way number 1. So I can rewrite this as 4 times 3. 4 is my perfect square, so the square root of 4 is 2. And I can't do anything with the 3, so the 3 is going to stay there. So my answer is 2 square root 3. If you don't like it that way, again, you can do the prime factorization. I have 4 times 3. I can keep going here, 2 times 2. So my 2's are a pair, and I'm going to underline what's left. So 2 is coming out, and my 3 is staying in. Okay, so let's go and check IXL and see if we got it right. So we need to make sure we're clicking here to get that square root. And we're going to put 3 inside. And we got it correct. Okay. Let's look at another one. All right. So we have the square root of 20. So I can do 5 and 4. Okay. I can keep going and get 2 and 2. So the 2's repeat, the 5's don't, so the 2 is going out and the 5 is staying in. So 2 square root 5. Or, if you don't like it that way, I can rewrite this as square root of 5 times 4. 4 is our perfect square, so 2 square root 5. Okay, let's check. All right. Now here I have square root 75, okay? So as the numbers get bigger, you may want to start to use a calculator just to make sure you're getting the numbers. One thing I like to do is just try different numbers and find different factors of the number. So let's say I multiplied this or I divided this by 3. I would get 25 times 3. Okay, now if you had me in person, I did show you guys how to use the TI Inspire to get some of those factors, so you can use that if that works for you. Okay, so I have 25. I'm going to circle that. Okay, the square root of 25 is 5. Then I have square root 3. Okay, or if you don't see it that way, you can still break it down. 5 times 5. Then you will bring out 5 square root 3, and that's my answer. So let's write 5 square root 3, and that's my answer. Okay, now let me skip because I know some of you guys say, oh, well, with IXL I don't get to the harder ones. So let's say, now this is just like the other one, but it's a number in front. We call that number a scalar. Okay, now don't get too confused by the vocabulary. It's the same exact thing. So let's act like the 7 is not there. I'm just going to worry about this 75 on the inside. Okay, so I have 25 times 3. So this is the one we just did, right? We know that we brought out 5 and then we bring out we're going to leave in the 3 on the inside, right? So I'm going to bring down 7. Okay, then the number I bring down, I'm just going to multiply. So this will be 35 square root 3. Okay, so let's go back and let's see if we got it right. All right, and we got it right. Okay, let me see if it's one that's going to be harder. Okay, so these are all pretty straightforward. So I want you to go ahead and try these on your own. And let me know if you guys have any questions. All right.